In this video we're gonna create this enemy which will patrol around the ground. Okay, and without further delay, let's dive into this topic. Okay, so find the first enemy, go to Sunnyland. Okay, then Opposium, I guess. So what are we gonna do? We're gonna select the first one. Okay, ideal one. Go to so I'm gonna select the first sprite and I'm gonna drag it to the scene view. As you can see, it's too small. So what we need to do, we need to select all of the sprite by holding down shift and left mouse button. Okay, go to inspector and select pixel per unit to less, so it will be larger. And if it's selected by bilinear, you have to select to point no filter. Okay, and then compression to none, and then after doing it, hit apply. Okay, as you can see, now it's large. So what we're gonna do, we're gonna name this. Okay, we're gonna name this enemy 1 or enemy. So go to inspector and name it enemy. Okay, so we also need to create the enemy script. Okay, we're gonna create firstly the animation. Okay, firstly the animation. If you haven't created the animation folder, just go over to assets. Okay, go over to assets, right click, create folder, name that folder to animation. Okay, we're gonna place all of the animation into this animation folder. So what we're gonna do, we gonna select that enemy, select all of the images, okay, as sprites. Okay, and drag it to the enemy. Okay, enemy, and it will redirect to you. So firstly we need to go to assets. Okay, so we will go to assets, then we have created this animation folder, so we will click it double. Okay, we're gonna call enemy something like run or enemy 1. Okay, so I will leave it as it is enemy. So hit enter and save it. So it will, if and go to animation tab and play the animation. As you can see, it's running. So what we're gonna do, we're gonna create a anime script. Okay, we're gonna create a anime script. So what we're gonna do, we're gonna flip this anime. Okay, to flip this, select that anime, go to sprite renderer. You can flip X and Y. We will flip the enemy horizontally, so we will select this X. As you can see, now it's flipped. So what we're gonna do, we're gonna create a enemy script. So go over to project folder. Okay, sorry, project tab and go to assets, right click. Okay, right click, create folder. Okay, name that folder to scripts. We're gonna place all of the scripts into this script folder. Okay, so double click it and right click, create. Okay, C# script. To keep thing organized, we have to create folders, that's why. So we're gonna name it to enemy, something like that. Okay, and hit enter. Okay, hit enter. After double click it to open up in Visual Studio. Okay, double click it to open up in Visual in Studio and head over to enemy again. We're gonna attach this script to our enemy game object. Okay, we need to attach this anime script to our enemy game object. So just wait for to compile. It will compile for a bit. Okay, we're gonna place all of the script into this script folder. We have to organize. Okay, that's why we have to create folders, so it will be organized. If we need something, we can go easily, we can check that out easily, that's why. Okay, so what we're gonna do, we're gonna firstly select the enemy. Okay, firstly we need two things. Okay, we're gonna add a rigid body which will responsible for adding gravity, and we also need to add a box collider 2D. Okay, for collision detection. So select that enemy and add component, and as you can see, an animator component has been added, which is responsible for animating this character. Okay, so what we're gonna do, we're gonna add a new component, find rigid body 2D. Okay, rigid body 2D and select that. Okay, we're gonna increase the gravity over here. As you can see, gravity scale. Okay, we're gonna increase by 3 unit, and we will select collision detection to continuous. Okay, it will detect continuously. And we're gonna freeze the Z rotation. Why? So if I select this rotator mode, as you can see, it will rotate like this. So what we need to do, we're gonna select the freeze rotation to Z axis. Okay, to Z axis, so it won't able to rotate like this. Okay, and what we also need to do, we need to add a box collider 2D, okay, for collision detection. So add component, find the box collider 2D, okay, box collider 2D, and edit the collider as the sprite sheet. Okay, I am gonna move it over here, for as you can see, you cannot able to see. Firstly we need to assign this, we're gonna assign a sorting layer. So what we need to do, we need to go to sprite renderer, okay, sprite renderer, you can see sorting layer selected by default. So what we're gonna do, select this, okay, we're gonna place the enemy sprite in front of our ground. So we're gonna add a sorting layer, okay, we will call this enemy. So it will be you can move it behind, but we're gonna move it front, okay, to see the enemy. So select that enemy once again and select what enemy sorting layer, what which you name it. Now we can able to see the enemy, okay. And we also need to we need to go to transform, select this to 0, so it will be like this. So what we're gonna do, we're gonna edit the collider. So go to box collider 2D and edit the collider, okay, like this much. So it will, you have to make it as sprite size, okay, as this is sprite. So I'm gonna make it like this, okay. Now it's fine, and unedit the collider. Now what we're gonna do, we're gonna attach the enemy script to this enemy game object. So what we're gonna do, go to script, and as you can see, we have created this enemy script. So we're gonna drag it to this enemy game object, okay, and double click it to open up in Visual Studio. So what we need, firstly we're gonna move this character, okay, move this character to the right side, okay. So what we're gonna do, we need to go to transform. If I go back to this component, okay, if I select the move tool over here, so so if I play around with x axis, as you can see of transform component, so we need this transform and the position x, as you can see, okay, as you can see, if we play around with x axis, we can go left and right. So what we're gonna do, firstly we need to go to transform, okay, transform of that component, transform, then translate. We have to use this function, okay, this function will take a direction, okay, this function will take a direction. So what we're gonna do, we're gonna go to right. So we have to type this vector 2 dot right. Basically this means x in the 1 and y in the 0, okay. If I head over to x in the 1, y in the 0, so we won't move in the y-axis, okay. That's why we also need a speed, okay. We also need a speed to so what we're gonna do, we're gonna go top of the class, we're gonna make it public, so we can adjust in the inspector. That's why we are making it public. So the type of this variable will be float, okay, floating numbers. So we're gonna call it something like speed, okay. By default you can set any value like 5 unit, like that. So I'm gonna select 2 unit, okay, 2f, okay, and we're gonna multiply this with, okay, we're gonna multiply this with our speed. So so this actually means x in the 1 and y in the 0. So x in the 1, so 1 into, as we know, we set the speed parameter 2, so 1 into 2 becomes 2, means it will go 2 unit, okay, 2 unit to the right side, okay, 2 unit right side. As you know, update function get call every single frame, so it will like go 60 frame, okay, let's suppose 60 frames. So 60 into 2, which become 120 frames. So it will go 120 frames in the right side, okay. So what we need to do, we need to restrict that, okay. So we need to also multiply this with time delta time, okay, to make frame rate independence, okay. Time, okay, time dot delta time means this basically means since the last frame time, okay. So it will restrict the frame rates, okay. So control s on your keyboard, sorry, I'm just missed. So what we are doing, so basically we are not doing it as start function, because a start function get call when the game start, and the update function get call every time. So that's why we need to add the speed every single frame. And what we are doing, we are taking the transform basically that component which is responsible for position, rotation and scale, and we have to use this function translate. This function takes a direction. Okay, this function takes a direction, so we will go over to the right side. Okay, right side, and this about this much of speed. As you can see, by default we set it to 2 unit, and we also have to multiply with time dot delta time to make frame rate independence. Okay, control s on your keyboard and head over to Unity. You will able to see. Okay, this will go to the right side. Okay, this will go to the right side by 2 unit. We will able to see the speed parameter over here in inspector, because we made that public. Okay, that's why we can adjust the value over here. Okay, you also have to make a prefab of this, means you have to make a copy of this object. If you lost from the scene view or hierarchy, you won't able to restore it. Okay, so what we need to do, go to assets. Okay, right click, create a new folder, and name that folder to prefabs. Okay, to make things organized. Okay, prefabs, and hit enter. So what you need to do, select the enemy game object and drag it to the prefab folder. Now if we lost from the scene or hierarchy, if I delete from the scene or hierarchy, I can drag it to the scene view, as you can see, and all of the same things have saved, as you can see the speed parameter. So if we now play, okay, if we now play, we will able to see this enemy will move to the right side by this amount of unit each frame, because we are doing it update functions, that's why. So just wait for to compile. As you can see, now it's getting. So what we're gonna do, if we select the enemy, okay, we're gonna create firstly we're gonna create a point from here. Okay, from something like here, and we're gonna shoot out a ray from here. Okay, and it will detect if we colliding with the ground or not. Okay, if we colliding with the ground or not. So what we're gonna do, so firstly right click on that enemy game object and create a child game object. Okay, name that game object something like checkpoint. Okay, checkpoint, and go to inspector, select any gizmos you can. So I'm gonna select the yellow one, and I'm going to move it over here, something like that. Okay, so what we're gonna do, we're gonna shoot out a ray from this point. Okay, if I select the enemy and if I move over here, if this array not detecting the layer, or if it's not colliding with the layer, so what we're gonna do, we're gonna flip the enemy in the y-axis. So what we need to do, go to transform, and we're gonna set rotation in the y-axis 180. So as you can see, it get flipped totally in the left side, as you can see. So what we're gonna do, firstly we need to assign this ground as a ground layer for layer mask. Okay, for detecting, so it will only check this layer. So what we're gonna do, firstly select the enemy and overrides over here. As you can see, this becomes plus icon. So what we need to do, we need to hit apply all. So it will change in the prefab, or the copy of the game object will also change with this will attach. Okay, so we need to this hit apply. So now it's saved. Okay, what we gonna do, we're gonna firstly assign this ground as a ground layer. So what we need to do, we need to select this. So I am gonna select this, I have this ground, as you can see. So what we need to do, go to inspector, in the right you can see layer. So what we going to do, we going to add layer. Okay, add layer, and we will call ground. Okay, and head over to that game object again, or the ground again, and say assign that layer to ground layer. Now we have. So we also need to overrides and then apply all. So what we're gonna do, we're gonna shoot out array from this point. Okay, from this checkpoint. Okay, from. So what we're gonna do, we're gonna open up the script once again. Okay, once again, and we also need to keep track of which direction we are looking. Okay, so what we're gonna do, firstly we're gonna so so we need to go to update function, because update function get call every time, and we need to check every time if we collide, if the ray is colliding or not. So what we're gonna do, we need to use this physics 2d. Okay, physics 2d dot raycast. Okay, raycast. So this will take three arguments. The first arguments where you want to shoot out the ray. Okay, and the second it will take a direction, and the third which layer you want to detect. Okay, so what we're gonna do, we're gonna create a public transform basically position. Okay, transform, we will call this one checkpoint, was checkpoint. Okay, and we are making it public. Okay, we are making it public. So so we will drag that checkpoint into this checkpoint, and we also need a direction and a layer marks. Layer marks basically layer. Okay, so what we gonna do, public. Okay, public, we will make it public so we can able to see in the inspector. We will call this layer mask. Okay, layer mask, you layer mask. Okay, so if I double slash it for now. Okay, so control s on your keyboard and head over to Unity. We will able to see two empty field, sorry, one empty field which is transform firstly. So what we need to do, we need to drag the checkpoint to that position, to that field. Okay, so we will have the position, and we also need to assign the layer marks as a ground layer, so we will only check the ground layer. Okay, just wait for to compile. Okay, just wait for to compile, and as you can see it says none transform checkpoint. So what we're gonna do, we're gonna drag this point to that field. Now we have this position, and we also need to, as you can see, layer mask selected by nothing. So what we're gonna do, we're gonna check only the ground layer which we assign it. Okay, so and then overrides and apply all to change in the prefab as well. So now we need to go back to again to that script. So what we're gonna do, we're gonna use this function. Okay, this function firstly take the position from where you want to shoot out the ray cast. Oh, sorry, the ray. So we want to shoot out the ray in the checkpoint. Okay, checkpoint dot position, and it will take direction. So we're gonna shoot out, okay, in the down direction. Okay, in the down direction. Okay, so vector 2. Okay, vector 2 dot down. So it means basically 0 in the x and y in the -1, so it basically negative, so it will go down. Okay, so and also it will take a distance, means the length of the ray, how much it should be. So we're gonna create public. Okay, we are making it public so we can adjust in the inspector, and that will be float type variable. We will call ray distance or ray distance length. Okay, or distance, short for distance. Okay, distance by default you can set it to any value, like I'm going to set it to something like 1.2f. Okay, sorry, 1.2f, 1.2f. So what we're gonna do, we're gonna as a third argument we have to pass the distance. Okay, distance, and the fourth will take the layer marks. Okay, means which layer you want to check. So layer mask, we will put layer mask as a layer mask. So this function over here, okay, it will be true or false if the ray is colliding with the ground layer. Okay, so this function over here will be true if it's not colliding with the ray. If the ray is not colliding with ground layer, so this function over here will be false. Okay, so what we're gonna do, we're gonna put this function into a variable, raycast variable. Okay, raycast, we have to type this raycast hit 2d. Sorry, sorry, raycast hit 2d, we have to put it into a raycast hit 2d. Okay, and we will call something like hit info or hit for short. So what this function over here, physics 2d dot raycast. Okay, this function will be true or false. Okay, so if the ray is colliding with our ground layer, okay, so this function will be true, so the hit over here will be true. If this ray is not colliding with our ground layer, if the ray is not colliding with our ground layer, so this function will be false, so the hit over here will be false. So what we're gonna do, we're gonna check. Okay, we're gonna check if hits equals to true. okay, equals to true, or just hit, it also means true. Okay, and we have to make this curly brackets. So basically if we are colliding, so what we gonna do, we're gonna debug, so we're gonna see in the console. Okay, so that's why we have to use debug.log. And let's say we're gonna print out the name of the game object what we are colliding with. As we know, we will collide with our ground layer. So the name of that game object will appear in the console. So what we're gonna do, we're gonna go to hit. Okay, then game object, sorry, hit, we need to go to hit, and then transform, then game object, sorry, game object 10 dot name. So basically what we are doing, this function over here, physics2d dot raycast. Okay, this function will be true or false. Okay, if the ray is colliding with the ground layer, so this function over here will be true. Okay, so the hit will be true. If hit is true, so what we are doing, we are just printing out the name what we hitting. Okay, what we colliding, so we are going to that game object transform. Okay, then game object, then we are just printing out the name. Okay, control s on your keyboard. Okay, head over to unity, you will able to see that. Okay, we will able to see a distance parameter. Okay, or the field, or is a float field. So what we're gonna do, we can adjust as we set by default 1.2 f by default. So just wait for to compile. Okay, just wait for to compile, we will able to see. Okay, just wait for to compile. As you can see the distance, so as you can see we cannot able to see the ray. To see the ray, we have inbuilt function of unity which is called on draw gizmo selected. So we have to go to the down. Okay, and we have to type the same name. Okay, on draw gizmo selected, you have to type the same name. So what we're gonna do, we're gonna draw a ray. Okay, so what we have to do, we have to do gizmos. Okay, gizmos dot draw. Okay, draw ray, sorry, draw ray. It will take a position from where you want to draw the ray. So we want to draw the ray from checkpoint. As we know, we will shoot out the ray from checkpoint. Okay, checkpoint dot position, and it sorry, checkpoint dot position. Okay, and the second parameter, it will take a direction. So as we know, we are shooting it to down, so we have to use vector2. Okay, vector2 dot down, and we have to multiply with our distance basically, we distance basically the ray length. Okay, the length of the ray, so we have to multiply it by distance. Okay, and say end up with semicolon. You can also choose a color for the ray by you have to type gizmos. Okay, gizmos dot color. Okay, color, you can select, I'm gonna select yellow color. Okay, sorry, color. Okay, color dot yellow. So control s on your keyboard and head over to unity. Now we will able to see that ray. Okay, by this distance or this length of that ray. So just wait for to compile, and we have to need to go to console to see if we are colliding with, if the ray is colliding with the ground or not. Okay, just wait for to compile. Okay, just wait for to compile. As you can see the ray over here, as you can see. Okay, so we can adjust the distance or the length of the ray, as you can see by this. So we're gonna make it a little bit like this much. Okay, so I'm gonna move it from here, I guess. Now it's pretty fine, and we have to override to save and apply all. So what we gonna do, what we gonna do, so if I move the enemy over here and go to console. Okay, go to console. If you can find the console, just go to window, then general, then console, control shift plus c. Okay, and if we hit play, we will able to see the ground name, because we assigned this ground layer as a ground layer, and we are checking layer marks, as you can see, by selected by layer. So we are only checking the ground layer. So as you can see in the console, ground just popping out, ground message just popping out. So what we gonna do over here, if we over here, as you can see, the ray is not colliding with our ground layer. So what so the if it's not colliding, so heat will be false. As we know, this function will be false. Okay, so this hit will be false. If it false, okay, if it's over here, means the ray is not colliding with our ground layer. So we're gonna flip the character. Okay, we're gonna flip the enemy, so 180-degree in the y-axis. So for this video is now. In the next video we will cover that. Okay, in the next video we will cover that. So lastly, thanks for watching this video. If you are new to my channel, then subscribe it. Okay.